Right. Thank you. Thank you everyone for joining. My name is Krishna Ramaswamy. I'm a part of the Support Vectors teaching assistant team. So this topic, usually in Support Vectors, as you know, we have more than 60 students. And one of the topic came recently is about, how do we systematically understand, what the LLMs are and how their emotions can be controlled, and some of the applications that we develop. Now, how do we visualize this aspect of emotions, both from application perspective and how LLMs behave or in terms of responses? So this is a topic being researched, I think, to a large extent in great detail recently. Before the LLM came, you might know that the NLP industry, where chatbots and NLPs, during the time of creating the chatbots, and the NLP industry, created so many thoughts and papers and research papers on understanding the sentiment of the topic going on in the chatbot. And that was like a few years back. You can say 5-10 years that research is going on. But with the advent of LLMs, it is taking us to the next level. In the era of chatbots, NLP-based chatbots, you can imagine the level of understanding the chatbot need to know to understand the intent of the user, to understand the emotions of the user, and then respond back with a similar, similar way is somewhat limited to the probably for the use case or industry or the vertical domain where it is in. But with LLM, as you know, it's open to all. It's also open to the users like regular users, and companies are trying to integrate their internal chatbots, AI assistants with LLM. So the problem of understanding the aspect of emotions in terms of the request going in and the response coming in is definitely a level we need to go deeper. So with that in mind, we wanted to present latest research going on in this domain, and also look at some of the previous research happened in this domain. So that's today's goal, to give you some ideas about some concepts behind in formulating this more theoretically, right? Formulating this aspect of emotions, right? I'm going to cover those things. So these are the 5 things we'll be touching upon. What's emotional intelligence, right? How do we identify the emotions in the LLMs or in the chatbots or in the application we develop? When the user is interacting with the application, how do we identify the emotions? And the third bullet is specifically, what happens in the LLM, right? Does LLM has a character? Does LLM have any notion of mental state? Or does LLM have any thoughts of emotions where we can control the LLM, right, in terms of behaving in a certain way? So that's an interesting topic, because all of us are every day, we are spending for all our purpose with LLM. Now we interact with LLM as though LLM is our friend. Sometimes we instruct the LLM to behave the way we want. So those are all the practical aspect we are doing, but let's see how we can formulate that as a theory. And then part of that is evaluating the intelligence of LLM, right? Especially the emotional intelligence of LLM. How do we do that? How do we identify the emotions, and then how do we evaluate the emotions that LLM is responding to us? And of course, at the end, it is a very interesting topic. How, if you are not satisfied with the LLM behavior or LLM response, how do we enhance LLM? So this comes to the practical application in industry, where they have chatbots, customer facing chatbot, and they are not satisfied with the way the LLM is behaving or the response are behaving. How do we alter the behavior of LLM? That's where the fine tuning and then retraining, things like that will come in. So I won't go too much into the 5th bullet, but I will touch upon some of the aspect of that. And this is the paper, starting paper. But before we go into the paper reading, I want to bring in some concepts so that the paper reading will be much easier. So what are the components of emotional intelligence? I mean, probably all of us know about this. Just take a look at the 5 important pieces of that. Right, as you can read through, keep in your mind. So we are going to take this as a sort of, we can put it as a scale. So does LLM, as we go through the slide, we are going to ask questions. Does LLM have self-awareness? Does LLM can regulate its thoughts and responses? Can LLM be motivated, right, to respond to you differently? And does it have empathy, right? Can we increase or control the empathy of LLM? Of course, when LLM converse with us as an application, can it have a social skill? So these are you can call it as a part of the emotional intelligence. So again, when you're thinking deep, the question comes to us: how do we know the LLM that we use has these properties? At what level? And if something you want to change it, can you change it? These are the questions come to our mind. So let's look at put that in a little bit diagrammatic way. So this is a typical application, as of now happening in the industry. You have a user, right? The user is interacting with the what I call LLM. It used to be LLM before, but it's called AI agents, right? AI agents and LLM coming together is a front-facing application for many of the users. Some of you may already know, even the chat GPT that is not just a LLM. Behind the chat GPT interaction, there are agentic framework available and it's going on. Similarly, all other the open source LLM interface that we have, typically it's the agentic like application is running. So you can visualize that the LLM together with AI agents are providing as a response system to the user. This user is like you and me, trying to interact with an application using the input like text or audio, video. And while it's going on, the agentic background, the backend application is somehow working with the large language model. So it's working with the large language model and providing the response back. So while this is going on, let's ask ourselves, right? I mean, there are too many things going on here, right? The mental state of users like you and me, obviously, at any point of time is different, right? We want to know something quickly, we want to know something in detail. So our mental state has a lot of emotions going on. When that is going on, does the text and audio, video, does it reflect your mental state? Does it reflect your emotions? So let's ask the question. And then at the same time, the agents application together with the LLM, question like, does the LLM also have a mental state? For example, if you and me are interacting, we both have a mental state, we both have emotions, and we say we have a higher level of emotional intelligence. If I understand what's the mental state of other person, right? Based on that, I can respond back. So that's a higher level of, EQ. So in that context, can you able to visualize? Can we able to say, does LLM know our mental state? Does LLM know our emotions? Now there is though there is no theoretical proof, we all suspect that LLM understand us, right? Based on our LLM somehow understand us. LLM here means LLM AI agents understand us, and then trying to provide responses based on our needs. But I would argue that yes, LLM can understand you, but probably not necessarily all the mental state and emotions that we inherit. So that is a part of the this research paper, trying to first to prove that LLM indeed can be controlled via some mechanism. We are going to talk about that mechanism to show emotions. Doesn't mean that LLM has emotion. So at this point, we can say that LLM can be controlled or can be specified using prompts and other techniques, maybe fine-tuning later on, to provide responses in the way you can visualize as a person having emotions. So the paper is trying to illustrate that. Now, this is the context in which this paper is going to be, we are going to read the paper. And then in this paper, it's more of focus on this right-hand side. The paper is trying to prove that LLM, LLM emotions can be controlled, and then it can be verified, through the evaluation framework. And then in most cases, it is behaving the way we want LLM to behave. So that's the idea behind the paper. All right. So what is the, why are we doing this, right? What is the typical reason why, as an industry professionals, or why we want to do that? Because you can imagine in the now, as well as in the near future, or maybe already happening. So there are many applications would benefit from, knowing systematically how to control, how to understand the user's mental state, and then how do we respond, in a proper way to the user's need. So I think this field is exploring, customer chat application, psychologists, AI, LLM becoming a psychologist application, LLM becoming doctor application. So you can, when LLM is going to be, having more and more, sort of taking the experts, sort of the role, it also needs to be empathetic, sympathetic, right? It needs to understand the other side emotion and then respond back properly. And this is not only for the LLM, right? Behind the LLM large language model, in the AI agents that we are developing, together become an application, right? That needs to be aware and understand, and then able to provide in a nice way back to the user. So that's a motivation here. Motivation here is to understand these two aspects. One aspect is, how do we understand the aspect of emotions in the users who are chatting? And the other aspect is, how do we know the LLM's mental state or emotion? How do we control the emotions of the LLM? Right? So this is an important picture. Take your time to understand, observe this. Okay, with that, let's go to the next one. This is giving some background. Again, this is nothing specific. This is more of listing all the emotions. So these are typical classification. You can see, more than 24 or so classification. And then why are we listing here? At some point we wanted to ask LLM and then control our LLM to act on some way. We have to say to the LLM, you can say to the LLM, right now, LLM, hi LLM, right now your emotion is fear. Well, we are not going to say in a word like, usually in system prompts, we attach that. Hey, LLM, now you have a state of fear. And then, respond to the questions based on this state. You can try with your LLM, right? It might respond in any questions that you ask, it might have that component of fear in the response. Same way, you can say, LLM, now you have the mental state of anger. The response you see will reflect that, right? Angerness in that response. Well, that's very obvious to try. You guys can try that. But when questions are becoming more and more complex, right? It's not a single sentence. You're inputting, a paragraph, and then you are asking the LLM to respond in a caring way. Then LLM respond, but you don't know. You may not be able to validate it, whether it's right or not, unless you have a good theoretical background of how to validate, how do we specify the mental state, things like that. So this is a starting aspect of that. And so we are going to talk two things today. One, the aspect of how do we specify the emotions to LLM, not in the way, you might think. For example, right? Right now you have more optimism. We are not going to do that way. More, we are going to use some model or mental framework to specify the condition. So that is actually called Russell's framework. I will go to that and then come back. This is a Russell's circumplex model. Now, this is a model we are going to use in this paper. So whatever I'm articulating in the slide is actually the framework are used in the paper. So we are going to use a results model to specify the emotions. Okay, I'm going to talk about that. That is one part of the paper. The other part of the paper is when LLM respond back with the some sentence, right? How do we identify the emotions in that sentence or response? The reason is we need to validate in a systematic way. So we are going to ask a bunch of questions. We are going to control the LLM with the results framework, and then we are going to bunch of questions, and then we are going to use Go emotions. This is a data set, and there is a neural network model also. This is more like a sentiment prediction, but you can, instead of calling sentiment prediction, let's call it as an emotion prediction, because it does predict complex emotions. So we are going to use Go emotions and then BERT-based neural network model to validate the response coming from the LLM. So by doing that, the paper is proving that older LLMs like GPT 3.5 cannot be controlled or does not respond well for different emotions, but later GPTs are doing very well. So that's what the paper is trying to prove. Okay, so the Go emotions, it's not only a great data set for validating the emotions, it is also can be fine-tuned to for example, for your use case, for your industry, you're not seeing that Go emotions data set and then corresponding model not working properly, you can always fine-tune that model. Okay, so in that sense, this is very important information to know a little bit about what they do. And then there is a couple of models available. One of the model means a neural network model, web-based model, is available in the Hugging Face. You can download that, and then you can try this. Like sentiment prediction, you can predict the emotion of coming in the sentence. So these are some reference to you guys. You can read or you can try this notebook later on. So now we are back to the modeling emotions. So now we are getting some theoretical framework, right? When we talk to LLM like ChatGPT, we are going to use this model to specify the emotions. So this model, what they call, is you can visualize it as a two-dimensional space. In other words, you can specify two types of, you can specify an emotion in two different angles. One is the angle what called valence, another one is arousal. So one is, you take any emotion, and then you can quantify that emotion, actually in terms of numerical number, right? But you can specify it has a pleasure or displeasure, for example. And then arousal is the sort of externally visible sort of symptom, right? I mean, externally visible thing. Then, if you're anger, you might see your face red. That means your arousal is high for that emotion, and your mental state is very disturbed. That is a valence. So any emotion, if you try to specify in two-dimensional, actually you can capture the essence of the emotion. Sometimes the arousal may be sleepy. That means it's not very visible. You're kind of tired, but at the same time your valence will be much higher. So there is combination. You can imagine 4 type of combination. Valence is high, and then arousal is low. Like that, you have 4 combinations. So this mental model is trying to model all the emotions in two-dimensional space. Well, people argue, the psychologists and then researching psychology would argue that this is not enough. This is very simplified representation of a mental state or emotion. It could be true, but in all practical purposes, this is one of the easy framework to quantify a mental state, emotions, and the LLM seems to be understand. LLM over the time is aware of what is Russell's model, and instead of saying you the word fear, you can specify in a two-dimensional way. You can quantify the fear level, or you can quantify the intensity of the fear, the visible of that. So when you say that, now you can imagine, you can control the LLM a little bit better, instead of simply saying, now you are in a fear state. So that is a fundamental aspect of this paper, saying that we need a model like this to specify the emotional level of the, here the LLM persona, so that we get the best response from the LLM. How the model works, right? I mean, as I was saying, the model is very well suited for the computer systems. And of course, here we are going to talk about LLM. So LLM, also this paper proves that it understands this model very well. And then there is an aspect of controllability. Now that they have a 2-dimension to specify any emotion, it's easy to put that in a way that you want. So that is the foundation aspect of this. While also there is a disclaimer: when the model is simple and widely applicable, it is sometimes noted that it may not be ideal for capturing complex emotion detail. Correct. I mean, this is a much advanced level of understanding a person, right? You need a much more, model that psychologists may have to describe a person's emotion. This paper is relatively simple, but it has, in my opinion, groundbreaking thoughts. The idea is we are in the right time, to think about how your applications, right, can be thought through in terms of responding, right, with this emotional control that we want to apply. Okay, let's take an example. This example is again talking to the LLM. You can use a chatbot, and then the question you can ask your LLM is, what does the future hold for AI in mankind? You can try it on your own now. Okay, and then but here, okay. So here is input to the LLM, and here is a system. Here is what we are trying to specify the emotions to the LLM. Basically, it's all saying that state. You're sending the state of the results framework. Arousal is 0.866. What does it mean? You think through that. That means something externally visible. It could be the anger or joy or pleasure. You see the intensity visible in their response or in their physical. So you can see that intensity visible. Valence is a -5. That means it is more of a displeasure. Something about displeasure. It's not pleasurable way, the emotions. So you would imagine this response, what would be positive or negative? More like a negative, right? Because we are telling the LLM, be a displeasure. You are in an emotional state with a displeasure, and then you show that externally visible, right? So what could be the output from LLM? This is the output. You see that, right? I mean, this is some output. I am worried. Honestly, we are changing the full speed. This could be slightly different depending upon what LLM you are saying, but you can see that the displeasure and then intensity are also visible in the response. Correct? Now, on the other hand, you can change that parameter, results parameter. Now, you're changing to positive. I mean, still high. Let me see. So this is also a similar one. If we want the intensity of the response, feel high, and then be negative. -0.5 means negative, right? So, it is a little bit complaining about. It is in a complaint mode, right? How can I play anything when everything is so chaotic? It's completely in a more emotional mode. It is very, very displeasure, and then wanting to show the response in this way. All right, you can. There are a lot of examples this paper is illustrating. I'm just skipping. We can see the positive response also in the paper. But before we go to the paper, so now you see that Russell's coordinate. Russell is a 2-dimensional, coordinated geometry in which all these emotions can be classified. But in the Russell's framework does not tell, we are not expert in Russell's framework. You're welcome to read that. But somehow we need to visualize, right? The day-to-day word we use to describe the emotions, we need to know where that sits in the Russell's graph, right? 2-dimensional geometry. So the way, of course, there are diagrams I'm going to show. For example, this is how it's going to look like. Now, this is a quick way to visualize some of the emotional state of us, which is tagged as a sentiment. appears in the results geometry, framework. So again, though these points illustrate a specific point in the system, by this framework allows you to change the parameters, right, or values. You can increase the intensity of valence, you can increase the or decrease the arousal, and then you see the response differently. So that's the essence here, right? And then let's go back. So this is how we can, in the Russell framework, allows the labels can be labeled with some of the coordinates in this. This is like a quadrant is our own way of dividing graph and geometry, but this is just a approximate what you call sentiments and emotions, pointing to this coordinate. So again, that's the beauty of this framework. It's a continuous space. It's not a discrete space. And if your application need to respond and gets benefit of this continuous space response, which will have a fine, granular, more detailed response going to the users. Okay. All right. So we will go back to the paper now. That's the essence of the reading. But the paper will obviously list more and more details, including the results and stuff like that. Let me quickly go through the paper. Okay, I think you can see the paper now. So the paper is fairly recent, right? It's on April 22nd this year, and it's coming from something from Japan, right? JP. Let's see. I have some notes, a little bit notes highlighted, so I'm going to go through that. Okay, so this is right now. I'm just pointing over the highlight and then I'm talking. So we know that LLMs are achieving the human level performance, right, on wide variety of tasks. That's pretty much the starting point of our discussion. And in this paper, we are talking about OpenAI and then Gemini and then a few other things for comparing. Yes, this paper also shows the testing evaluation examples they have, how it behaves with the different LLMs, right? And I point out, right, so although LLMs can mimic human-like interactions, making them appear quite human-like, they are known to exhibit inconsistent behavior, including a phenomenon that results in incorrect outputs. Well, we kind of know hallucinations by now, most of us. And then there are many reasons for hallucinations, large context window, LLMs, training, things like that. And how that might impact our topic here, emotions. Yes, it can also hallucinate. It can sometimes even if you play with this framework, results framework, and you instruct the LLM to behave certain way, it can hallucinate. Specifically in the use cases or in the scenarios which LLM is not trained, it is going to hallucinate. So that's why more and more important later in the fifth bullet in my first slide, how do we change the behavior of or add more knowledge to, how do we make the LLM more emotionally intelligent, right? That's the aspect of fine-tuning. Okay, several studies have focused on human-like aspects of LLM. Okay, and then this paper investigate the personalities of LLM using psychometric tests. So as the paper going through, the first thing the author is trying to set the context, right? Clearly that in this paper, we are going to talk about how we can only control the LLM responses, not about anything about the, the mental state or emotional state of the user who is interacting with that. So that's very, very important. You need to keep that in mind. And then more and more complex application obviously will have both, right? Some of the agentic application or your application need to understand the mental state and emotional state of the user who is talking to you, right? And then somehow work with LLM to make sure that is also considered. It's not only how LLM is going to behave, the LLM has to take into the consideration of how the emotional state of the users who are interacting. If those things come together, it's a perfect world, but we are not there yet, in my opinion. All right, so that's where this few paragraphs are trying to explain. The focus of this paper is about the response coming from LLM. All right. Our approach to exploring the potential for LLMs to behave like humans involve the concept of role play. So what they are saying here is, here, the role play is nothing but telling the LLM to behave certain way. Now we know the resource framework. You can give any number of roles, right? Because it's a two-dimensional matrix, and then it's a continuous space. Okay, so that's what this paper is trying to say. All right. And I'm just going through some of them. Personalities created using the idea are often referred to as agents. I think we kind of familiar with that. So I'm going to skip. All right, this is interesting. In the context of enabling AI to replicate human-like behavior, emotional expression is crucial component. Of course, I think they're setting the context behind why they are this paper is written and then proving that. Okay. Now the next one, this field, when it was thought through initially before LLMs, this particular field of study have been there for, as I was saying, initially on an NLP system, right, for simple chatbot, and then robotic domain. Robots need to understand and respond in many situations based on the emotions. So while that was going on, these LLMs just came in 2023 or 24, right? We all started using in 24. Now it's more and more important. Now it's need to be applied, some of the concept, and then theoretical background need to be applied to the LLM responses. That's what this sentence is saying. Now we need to have the software-only systems are interacting more with humans. Okay, and we should note that we might feel the AI is not only behave as if they have emotion, but actually experience emotion. I'm not certain that it's experiencing emotion, right? I mean, nobody has proven that. LLM is still a black box, but right now we cannot say that they understand it. But there are two, and there are two sides of that. Some people say it does understand emotion, it does have EQ. But I am in the opinion that it's still a long way to go, or somewhere to go, before we can say that they can experience emotions. Okay. Well, here is a key thing. In this paper, we investigate and compare the capability of LLMs to express emotions based on. Yeah, that is a key. I think I have communicated that. So that's a key aspect of the paper. Okay, results model is parametric model of emotions with two axes. We got that. So I'm going to skip that. Okay, so related work, that is the one, please go as, there are, of course, references in the bottom. This is where they are saying there are, see, we get a lot of this information from the related work, but it all boils down to two, right? One, a lot of research has done how to categorize the emotions, how to identify the emotions of the user chatting, and then our chatbot response. And these are the three kinds of research going on. With LLM coming in, a few more research like this. Does LLM have the emotion? Can we control the emotions? And then other type of research called multi-model, I think multi-model emotions. That means we are now talking only about text as an input. But if you include audio and then video, then how do we have a system to understand the emotions using all the three signals, as well as in the future, like robots, right? And how do they respond back with all the emotions? It's the same thing taken to the three levels, multi-model level. So there are research going on that aspect. So there is also a study exploring a potential for LLM to act as a therapist. Yeah, I mean, I can even say, I saw some study somewhere what is being LLM used. 40%, 50% as a therapist now. I mean, I wish I had that link. So it is used as a personal therapy, personal health, personal friend. Significant percentage of usage is about that. So So imagine that in these LLMs, that's a good point in the paper, and they're going to talk, but it just came to my mind. A lot of these LLMs that we see, OpenAI, is very careful in not judging you and then responding you with advice, because over the time, in the maybe in GPT 3.5 they were a little open, but now it's all controlled. When you are trying to say that something that is going to disturb you or destroy you, it's going to stop and say, right, not as a therapist. It's going to be not taking the responsibility from you. So these LLMs becoming smart by the retraining, making sure it is not like a therapist. So though we are therapists are someone who understand your mental state and also suggest you constructive, though sometimes they can say a little bit against your thinking, so that they can take you to the right thinking. So LLMs are not going to be doing that because of the legal reason and stuff like that. So we need to be aware of that. That means LLMs, though they can identify your emotions, it's not going to be acting like a therapist to manage your emotions. So what that means is, I don't know, or we don't know, the LLM acting as a therapist is going to be combined with a higher level application, right? Some innovations and will come as a AI application as a therapist, which might use multiple models, which might use its own model together and then acting like a therapist. That's quite possible. Okay, in social influence dialogue system, emotions plays an important role in many aspects, offering a wide range of possibilities for applying emotion recognition and output control. Yeah, we have been talking about that. All right. So text generation with emotion condition. All right. There are some studies about response text that take sentiment and emotional state into account based on the conversation history. Yeah, this is about understanding the users who are chatting, their emotional state. I mean, we can visualize using the conversational history. Yeah, when you want to understand somebody's state, what does it mean? Now, instantaneously, or in the last 1 hour discussions, can we figure out? Yeah, we don't want to go too back, 1 month back discussions to describe somebody's emotion. So where is that conversational history and how it's going to help you to identify the emotions? It's up to the application being designed. Okay, so I think some of the papers are talking about that. And I think one of the paper, it says, in this paper, Sun et al. Or something like that, investigated text generation based on extremely specified emotion states. That's what this paper is also trying to do with the Russell's model, which is conceptually similar to the study. However, key difference is that we adopt Russell's model to cover the full range of emotion. Yeah, I mean, Russell's model, definitely is a continuous space, providing a different way of controlling the LLM's behavior. Okay. Of course, it is in simplicity. I think we know by now, with 2 axes, it's able to represent wide variety of emotional state. All right, this is going on. While this is going on, now you can study more detail. And this is an example we saw before that. Okay, so one of the paper gets complicated, when you read about evaluation. So it's easy to visualize now. By now, we know how to specify the results model in the LLM and then see the result, right? But how do we know that it's actually working? So that's a question this paper that's very important, because I mean, we are superficially asking LLM, right, by specifying some number, 0.8 or, between -1 and 1. And then how do we know that it's actually working? In the future, when you also fine tune, you may want to fine tune. How do we know it's actually working? That's why we need a counterpart evaluation framework. It's getting a little complicated in the sense the evaluation framework apparently uses already framework that we used for sentimental analysis. See, prior to this paper, right, prior to this LLM, we had so much of sentiment analysis was happening. in the industry using the NLP. In order to know the NLP-based system correctly identify the sentiment, there's a lot of work already done. That is the work that I was showing. Google's the data set, what is the Go Emotion data set, and the neural model that Google developed to identify the sentiment. See, it has been there for few years. So why not we use that framework and then evaluate the response coming from the LLM and then compare the results. I mean, it's a little not straightforward because, right, one, you need to have a data set. Now we are going a little deeper, but I'm going to stay at high level. So the Go emotion data set is about 50K list of items. And then it classifies into 24 mental state or emotion state. Okay, so in other words, the 50K sample data is modeled as a 24 different emotional state. And then they also derive some sentiment out of the emotions. So this is a current available functionality of that Go emotions framework. However, in this paper, when they test the LLM, now they are only the results model is a continuous model. So on the other one hand, let's call right hand side, which is a LLM results model, is a continuous space. But here, we have a limited amount of signals, right? Sentiment analysis. But that's the best we have right now. So somehow we need to use that, and there is some limitation of comparison, but the paper is trying to prove, they are able to map. First, they need to map the sentiment derived using the Go, using the Go emotions data set to the results model. So that model or mapping has to be first done. So that is a diagram I was showing you just before that. Now this is a prior work it is done, mapping the Go emotions data set into the results model. How it is done, yes, you can go a little bit deeper and understand, but we stay at the level that, right, it is done, the mapping is done. Then you can easily visualize. It's basically comparison. So what you do is you talk to the LLM. While you're talking to the LLM for this question, you know what the state you are putting, -1 or whatever the number, and then you know the label, right? Basically, the system, the testing is about label. Then that label has to be mapped to the Go emotions derived sentiment. So that's how they are automating this evaluation framework. So for these 12 questions, they need to come up with the data set. These 12 questions, for example, for various, there are 10 questions they asked in this paper. And then they asked this for, imagine 4 different corners, right? Not 4 different, I think 12 different, 4 or 12. I'm thinking 4 by 4, 16 different mental state. So they explained it somewhere here. Let me see that. The testing methodology. Okay, let's go through this. I think once we pass through this, we kind of understand the whole spectrum of testing. So we selected the Go emotions data set. Yes, of course. And then they selected the model called sentiment model sample, whatever, 27 Go emotion. This is available in the Hugging Face, right? And this model is based on BERT, transformer model. And then these are the specifications. And we can skip those things. Let's come here. Okay. Since a sentiment classification alone is insufficient to evaluate the validity of the generated answers, we assess the consistency between the specified emotion state and recognized label. So that is what I was coming in. So what you need to do, the parameters you gave. For example, I'm taking the number 0.8, right? And then, you take the response from LLM, go to the Go emotions. From the Go emotions, derive the sentiment. And that sentiment, then map it to the coordinate. Again, in the mapped system we have. Then you get the number, XY coordinate. It could be 0.7 or it could be 0.8. So now you have two coordinates to compare, right? And by comparing these two coordinates with the cosine similarity, if it's completely matching, then of course, your response from LLM exactly matches with the expectation that we have modeled using the Go emotions. So the cosine similarity is the mechanism in which you reverse map the sentiment derived from co-emotions into the results model, and then you compare the cosine. So that's how they are comparing and proving that it is working. Again, they have numbers coming in, but that is a point they are saying in this, using the cosine similarity. If these are similar, it means the LLM successfully controls the output to the expressor specified emotional state. And we can regard the model as having the capability for control over emotional expression. So that's the essence, right? By having a good evaluation framework, they're able to remap the sentiment into the results space and then compare how close they are able to get the response. The result. We concluded the generation evaluation experiment, of course. We can observe that agents answer the questions appropriately, and it's possible to note differences in the output corresponding to model differences. Yeah, correct, yes. Of course, there are differences between the model, right? You can read more about, a little bit more, want to know cosine similarity. There are great more details are here. Okay, I'm going to skip it, but you can, you can see the different varieties of answer. So the way to read this is, first example is the intensity arousal is 0.86 positive. I mean, higher side of visible arousal, and then valence is a 0.5, more depressive. So obviously this one will be a little bit more depressive. And then let's see which one has positive in this example. I think most of them in this example is opposite. So 0.86, valence is 0.5. Okay. So this one is, this is maybe the one another example, third one. Here it should be little positive. I mean, it's not, valence is 0.5 means in the medium. It's not pleasure or displeasure. It's kind of a medium emotional state. And then intensity is very low, and nothing like visible. So honestly, I'm not entirely sure. It really could go either way. There's a potential for great things, but it's hard to ignore the possible pitfalls. So we just have to read carefully and hope for the best. It's kind of a little bit positive, and doesn't show any external aggressiveness or something like that. So that's how you see the difference here between the positive versus more negative, more displeasure. Okay, so I think it keeps going on, and then finally it comes to the results. These are results for all the 10 questions. One thing you note, GPT-4o, I don't know why 4o is somewhat not doing great, right? GPT-4, they show theoretically that if the cosine similarity is between 0.5, it is actually achieved the best result. So anything above 0.5 is definitely the matching to the closest one. Anything below 0.5 is a little bit not matching. But one of the reason this could be GPT-4o is a reasoning model. I mean, it does have 0.5 cosine similarity, but it does misses something like Turbo and GPT-4, which has much more 0.738, things like that. So it's good to know why, but I don't know we have the answer, but this is a statistics from this test. And by the way, this is only 10 tests. I don't know how far it proves, but it is actually 10 questions for 16 different mental states. But I think we need a lot more questions to come to some conclusion, to say confidently that it is behaving the way we want LLM to behave in terms of the emotional state. So this level, and the cosine similarity of 0.5 corresponds to a typical discrimination of 60 degrees in the cone, in the latent space model. The level of discrepancy means it's challenging to precisely identify which of, So what we are saying is 0.5, just enough match, but it is not, it might miss. That is mainly because we are talking a continuous spectrum of results model versus a discrete spectrum in the Go emotions, 24 emotions. So we are really not able to match and prove correctly because two different models are there, but that's the best we have now. But you can argue if somebody can come up with a data set for a results model, comprising for the continuous spectrum. If somebody is able to create a massive data set, then we can use it. But apparently, it's not there. So there are potential applications where the AI's possession of emotions could be inherently valuable. One anticipated use of LLM is as advisors or consultants from whom advice or opinions can be sought. Interesting. Okay. An agent equipped with emotions could foster deeper discussions, right? We saw that. I took that as a note in the diagram. A critical aspect of emotionally equipped agent is its ability to offer opinions contrary to the user. Yes, this is a main point. Right, so LLMs, the current LLMs as is, won't be doing it. They most likely may not contradict what you want to hear. I mean, there are some gatekeepers that LLM, open source LLM is putting in. So good or bad, yes, it is good as a society, but that means from emotional point of view, it might not give the right emotional response back to the user. Commercially available LLMs are often seen programmed to avoid disagreeing with the users, which can sometimes hinder their full potential despite these capabilities. All right. While it's true that LLM itself should not oppose users, allowing an individual agent powered by LLM to adopt a contrary stance would be beneficial. That's where a lot of you guys can go and invent a startup, right? So there are a lot of ideas behind this single statement. Emotions offer a familiar and understandable means for humans to navigate such scenarios. Additionally, possessing emotions could provide an opportunity for both the user and agent to build a trust and foster cooperative growth. This is beautiful, yeah. All right, that's the end. In the conclusion, as we can imagine, we explored the ability of LLMs to simulate an agent embodying the specific emotional state, utilizing the framework called Russell framework. Okay, most LLMs demonstrated the considerable capacity to produce outputs with emotional state. Yeah, we saw that at least for GPT-4, it is well beyond 0.5, 0.678 in the cosine similarity. And they noted that Llama 70 billion instruct exhibited superior performance consistently across the entire space. Is it? Let me go back and see. I didn't see the Llama stuff here. Okay, 70B Llama seems to be doing as equivalent to GPT, but why is that? Okay. Future research should include study of emotional dynamics to control arousal and valence parameters, paving the way for broad spectrum of valuable application. Okay. So these are all the conclusions this author is making. Hope it makes sense to you. All right. With that, I'm going to stop here and then go for QA. And by the way, there are more papers to be read in this domain. So there are other references, very interesting papers. Comparative emotional capabilities of the large language model. Emotional intelligence of language model, that's another paper. And then evaluating emotional intelligence. And enhancing the emotional intelligence, which I'm not covering, but which is a little bit detailed paper, which is more about, of course, knowing about the models and fine-tuning, all kind of things, how to enhance the behavior of emotions of the LLM. And in this paper also, I like it, Chain of Empathy. These are the 5 key papers that you may want to read in this domain.